Welcome. Let me just make sure everything is set up and going as we would expect. All right, looks like we're all good. Apologies for the late start today. I know it's almost noon locally for me. I would like to stream the full 4 hours, but I can't guarantee that. I'm hoping for at least 2 hours, ideally 3 to 4 though. So, just a heads up. That being said, the intention for today is to continue on with our procedural generation work that we've been doing. I guess I can switch over to that. Do coding. We are on a current scene. This is where we left off yesterday. We are able to generate a start point, an end point, guaranteed hallway to avoid enemies, guaranteed hallway at the end. Well, I guess not guaranteed hallway, but a randomized location for spawn point. I was thinking about this. I think we should add a 50% differential on distance as a minimum threshold. So let's add that to our exit logic so that our exits aren't too close to our entrances. But this will give us a pretty good option. The alternative that I was thinking for this that might be a better option is we always put it in one of the, the top or bottom corner. In which case, I don't know. I'm a little concerned because that means that no one will ever take the middle path. You know what I mean? Once they figure it out. So a randomization solution like this gives us a better variety. So we don't have to worry about people just completely avoiding entire areas, We'll give that a start. Let's set a threshold distance. So we have this distance. If we tweak, let's set a modifier as 1.0. And then we can take our if we multiply this by modifier, nothing will change in our original algorithm. But we can now generate a secondary exit location. Let's do that before we place our exit. So this is our exit. So before we place this, let's generate actually. So we've got the primary exit, which sets our dimensions. We square it out. And then if we change this to be a secondary location within 0.75, it will always be within the generated area as a vector 2. We don't need to do anything else past that. So we can just set that. Because it's already randomly generating an angle. So if we run this, interesting. I didn't think about that. That is a bit of a weird one from generation. The initial boundary point was set pretty much straight up. And then our exit point was set at a much smaller angle. Not sure how I feel about that one. I don't know why we're getting so many like extreme angles like this. When we ran this yesterday, we almost didn't see this at all. Now we're just getting spammed today. This is another one. Well, I guess we have to be okay with outliers. I'm gonna make one tweak on this. So if let's do, we're marching through here, we're building that, we're grabbing our count. Let's do count -1. We're gonna grab count plus direction. Or sorry, location plus direction. Location plus direction. And this is not a hall. So there's no chunk here. Then we get a hallway. Otherwise, intersection. I want to guarantee that our exit branches off of an intersection. So even if this is an oddball intersection, I think we'll need to just do something to fix that later. But now we get an intersection at that junction point. Oh, I didn't even think about that. I guess what we need to do here is while. Do I really have to duplicate this? Man would do while loops be nice. GD script do while. Yeah. Emulating with while true and break. Oof. I mean, it's technically not wrong. All right. So while true, we're going to go through and we're going to choose a location. Then we want to do chunks dot has tile location. So if not, then we set and break. Otherwise, we will repeat until we find one. That way we're not generating it into existing hallways. So we'll always have an intersection. We won't guarantee distance, though, on the exit. But it will always be an intersection leading up to it, which I have a preference towards. It can be anywhere in the outer 25% of the maximum range now, which I kind of like that. I think this puts us sorry. I think this puts us in a pretty good spot. I think when we're doing the traversal, when we cross over this point, I think while we're doing this traversal, we just need to do stepping, and then we just need to set intersections when we come across duplicates, which means in our stepping function up here, So in all of these locations, oof. So I guess the easiest thing to do would be else. So at this point, all of these locations can either be a hall or an intersection. We add our exit down here, and our entrance is outside of this bounding area. So we shouldn't have a problem doing this. That solved nothing. It's because I didn't change this to be I. All right, let's try that again. Let's swap this to intersection. There we go. Okay, so now we have all of our overlap points being set. I'm noticing we're getting duplicates on our iteration cycle. We're getting a lot of duplicates in our... Oh. That's going to be a problem. So the marching for locked, or sorry, for Y's is 0. Man, I need to clean up this logic. I'm tempted to change this to where all of this creates an empty tile, but it adds an entry. And so we can just loop through all entries and check to see if it has neighbors that make it an intersection or not. Because that gets rid of our problem before, because we have another problem here. If you ignore the line of intersections here, the intersection every so many steps problem. We don't necessarily need intersections along these routes. I think I'm torn between using the existing intersections to determine POIs and fitting POIs and then determining intersections. With a waveform collapse function, we don't need to generate POIs. I guess we'll try it without. Let's clean up the duplication that we've got going on here, which is all tied to the locked Y, which is this first one. So if we remove this it should get rid of that problem, but it introduces a different problem. Path traversal. Damn. Yeah, this way of handling it isn't gonna work. I'm gonna have to update what needs to be an intersection retroactively. There. I'm gonna have to go through and just check if a tile is a intersection. It has the option of generating. So if a tile is a hall, it can potentially become an intersection. If it's an intersection, it could potentially become a hall. And a lot of that will be determined by what's around it and what generates immediately around it. I can go in now because we have a concrete area and add empty tiles in every location. Let's do that. All right, 4. Int it in. We need it to be to our x in range. Range works as a start in value, right? Yeah, beat in. Okay, so I can give 2 ints. So if we give it x starting point of starter intersection.x, +1. Yeah. And exit dot x -1. Then I'll remove the outer boundary. And then we can do for y in range of starter intersection dot y +1 and exit dot y -1. Because again, at this point in time, I don't think we've reused exit anywhere. We've generated a new exit location, but we never assigned it back to the exit variable. So yeah, we only consume exit everywhere. Which means this will get us our y and x values bounded within our container. If chunks dot has, let's do var chords equals vector to I of x, y. If chunks dot has chords so we have something here, we do nothing, so let's negate it, and then chunks dot set chords as a chunk dot new. Let's give this a any so we can just visualize it, and then down here any. Floor tiles. Let's use this. Stands out. 921. Okay, so I was not expecting that white border around the edge. So let's remove that. Interesting that it got this white band down here still. Oh, that's because I only edited the X, not the Y. Yeah, I was having issues with both. So Y. Boom. So now we can mirror this. So not only do we set chords, we need to additionally, duplicate. And use chords.y times equals -1. So we now have our full set of tiles. So let's do now that we fully, let's generate cells. Next, we want to take our generated cells let's remove this from here. We'll add it here. Render. So this generates every one of our cells and also gives us the hallway pathing function. Maybe I should actually separate those. So if we go down to the bottom of this, this right here is how we generate our cells. I am using our exit and our starter intersection though. Yeah, I don't want to decouple those functions because I'm passing a bunch of stuff around. I don't want to do that. Okay. So next up, we want to, we've gone through this. We also no longer using this, so let's remove those. Next on the docket, we need to find all edge tiles. Let's start collapsing. Wall collapse. For X in, no, for chords in chunks. We know it exists, so we can just do var chunk equals chunks dot get chords. We have Can't remember if I left a cat outside. I'm gonna go check and make sure I got all the animals inside. I'll be right back. I will go ahead and run a quick ad, I guess, while I'm searching for cats, just so that we get more time when I get back. Give me a second, I'll be right back. Sorry about that. We're back. I did manage to find all the cats. One of them was being stubborn. Let me switch the scene back over. Okay. We need to introduce our first wall. So we've been taking the floor layers so far. So let's take in a wall layer. We're still going to do the set cell. Or 1 vector 2i. All that stays the same. But we need to go to the floor layer and we need to tile set and we need to select. Nope, not floor, wall layer. Tile set, select. I have these walls painted. I wanna say those are the full tiles. Let me check the physics layer. Any of these will work. Okay. So let's select this tile. Which would be Atlas chords 11, 2. So now if we set a W, we should get a wall.
And now it's just like, man, you gotta have that time where you just like disconnect from the scene, just the race. Like, and it's a race
So
in
in
your head,
this,
away from it.
we want to check all on this pass. We want to, our main goal we have 2 goals. Let's call this wave 1 collapse. What we need to do as part of wave 1 collapse is we need to convert intersections as needed, add walls where required. Those are the 2 things we're focused on here. And so what this will do is it'll block in our navigatable areas and convert what we need to intersections. And what I mean by that is like this tile here at the end should be in, it should likely be an intersection. Honestly, in this one, I would like to keep like these corner tiles don't need to be intersections. But that's actually a quirk of the algorithm up here. So let's just fix that real quick. When do we deem it needs to be an intersection? If while traverse, is it the only time? Here's the other chance where it can become an intersection. Here we go. No, this has to be the one. So while iterating through, That sets intersections for everything. So if we remove all intersections, so if we remove this logic, our wave 1 collapse could do some cleanup on double lines like this. Remove duplicated side by side hallways. So we'll get rid of the duplication when we have the double hallway. We can add our intersection points, and we no longer need to get rid of intersection points. And then we can surround everything in walls. So let's do intersections. If match chunk dot value, if it is a hallway, then check the 4 directions. We'll do 4 directions. Const 4 directions equals. Let's do up, right, down, left. Up. Right, down, left. Up, right, down, left. Okay. So this gets it into a uniform. Okay, we have that now. We can use this as a reference point in here, and then we can use it as a reference point in here. This should be the items themselves. So for now, I'm just going to print. Is this patterned on items or, oh, right, I need to call the function. Is this pattern on indexes or the items? It is. Okay, perfect. So these are the actual direction segments, which is what we needed. So given a direction, bar, let's do hall count. If chunks dot hat, well, let's do this. Bar neighbor equals chunks dot get. This will set it into the array as a null value, which I intend to replace with a wall. Okay, let's get chunks at chord plus direction. If neighbor equals null, chunks dot set chords cluster as a chunk dot new wall. Elif neighbor dot value equals Paul. Intersection. How do I want to go down this? Let's not check for intersections. Let's check specifically for halls. Then our hall count increments. Afterwards, if hall count is greater than 2, chunk dot value equals intersection. We should have intersections and walls. We got intersections. I think our walls are incorrect. I also just noticed exit. Exit. I don't see an exit. Are we not generating the exit? I assume we're always generating the exit because I've never seen that happen. So exit. 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 I noticed it twice pretty quickly, so it shouldn't take much. Okay, let's add this back in. And then let's... Is there... Let's do it as a one-off inline. 4 chords in chunks. Var chunk equals chunks.get chords. If chunk.value, well, let's do match chunk.value. If it is our start, print start chords. If it's our exit, then we will print exit chords. We don't care about anything else right now. We found an exit. We have an exit. We have an exit. Did I add that? There we go. We didn't get an exit. The only thing I can think... Oh, I just realized something. I know exactly what's going on. All right, so we need to go to this function. No, I am checking to make sure the value. I only set wall in the case where it's not defined already. And I am setting it to the correct direction that we are checking. if it exists as a haul, then we haul increment. And the only way to update an intersection. So let me print override chunk dot value. All right, we have an exit. All right, we got one. According to this, it never overrode an exit. There's a, oh, I wonder if our generate cells. Not has. Not has. Let's do this as a vector to I. Chords.x, chords.y times -1. And remove this line. Oh, it helps if I reuse this. I think this was the case where we were losing it before. It seems to have fixed it. I've noticed our exit is almost always in the bottom half. That seems statistically unlikely. Oh, here's one where we don't have an exit again. I don't know why that's happening. I mean, it shouldn't be this. We literally doesn't exist, set. I don't know how we'd be overriding it on accident in that case. We have this tile location logic where we are assigning our exit location. Let me check this exit location. I want to see if, are we not? So we changed this to be positive, but it should also, oh, we never added our sign swap here. That's why it's always in the bottom half. All right. I put it to you there because I don't know after we do that if we're going to be able to recreate our issues frequently or if it's going to reduce the frequency significantly or something. So I want to look through and see if we can address the other issue first. Oh, man. I mean, this has to be setting an exit every time, right? Right. Sign. Exit. 819. This one's 0, 0. So 1, 2, 3, 4, 5, 6, 7, 8. That's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it should be somewhere around that. That's probably what this is done here. It's meant to be linked to that. Which says to me it didn't. Somehow this logic didn't pick it up. I don't. Okay, I'm going to change this logic pretty significantly, I guess. And since we're changing that logic, I'll go ahead and do this real quick. Angle times equals angle. No. That pick random. Where our options are either 1 or -1. Just make sure it's doing what I want to, not airing out. It's on the top. Doesn't exist. On the top. Doesn't exist. On the top. Top. I'm starting to wonder if it made it worse. Oh, it should have been on the bottom that time. Okay, it's on the bottom. We're getting some finickiness for sure. So to fix that, as soon as we have a bounding area, let's go back to our original idea, I think. And what we'll do is we will. There's a lot of code to just scrap, but I'm gonna need this. Let's, for now, we're just gonna comment out this. All right. So we have our range of tiles that can go into. And so we're going to get the coordinates. Oh, I should probably comment out this. So we created a starter location and an exit. And now we're just filling it in with any tiles. Both the upper and lower boundaries. Odd. We generated an exit. Doesn't exist. Creates it. Mirrors and creates it. being a negative x, isn't it? So let's take this. This should fix that. Yeah, that fixes that. Okay, so we have 1/3 pi. Oh, sorry, 1/8 pi to 3/8 pi. This is incorrect. If we wanted to go in a bounding range, from 0 to 3/8. Yeah, that's what we want. All right. And then now we should be able to add back in angle times equals this. Because the resulting angle should be 0 to 3/8 pi, which would be offset from y of 0. So it should swing down up to 3/8 pi radians. So the negative should just be the inverse swinging up of that. So why is that not working? I mean, the obvious thing here is I can just go boop, and then I can go int is here, so that's the same thing. Oh. Interesting. Is this something wrong with pick random? No. We're literally mirroring this everywhere. We're doing this logic of taking the positive value and converting it to negative or vice versa. That our entire duplication function is built around that. Yet it seems like it's coming out more than 50% of the time right now, but I'm willing to bet with large enough sample it's going to be 50%. Which would be the difference between this getting selected and this getting selected. Is this somehow not coming through as an integer? Yeah, I mean, we could test it. If I do that, if it shows up working every time, then we know it's negative. Whenever it chooses -1, something goes wrong. Okay. Well, if we lock it to -1, that doesn't make sense to me. You can have negative y values. I need to know which of these is greater is the problem. In the cases where it comes out negative, our exit is now a smaller value than our start on the Y. So I need to know our start is locked. X will always be positive. Sorry, X will always be positive, Y will always be 0. X will always be a larger positive number. This isn't true. This should fix it though. Yeah, okay. Angle times equals or pick random. That works consistently. Okay. What if we change how we define bounding areas? I like the variability we have. Maybe I just restrict the angle more. Which would mean I reduce this number. Or I could increase this number. If we increase this by pi is the lower value, so pi, let's do that, times 2.0. I don't like this as an exit location generator now, but which means we don't need the angle logic. Let's do so this is still valid. Okay. Next up, let's grab this that we did here. Pop it in here. And instead of return, let's set the var bounds. And then in here, we can do bounds. We no longer need absolute value. There we go. This will generate our playable area. Next up, we need to find an exit location within the playable area and generate our walking function for it. So let's do that. We have a size. So var exit. We have a size. So if we do a vector, vector to I, where we use the range, int range from just check something real quick while I'm thinking about it. All right. Based on how we generate this, it shouldn't be an issue to use bounds dot x divide 2 bounds dot x bounds dot y divide 2. No, we can do 0 on this one. 0 to bounds. Oh, and then I need to do x. I actually need to do Randy range 0 to bounds dot y, which is always positive. Meaning this will always be positive, but then we can multiply this by 1 negative 1 dot pick random. And then we can chunks dot get. No. Chunks dot set. Exit. Chunk dot new. Exit. Exit being generated. All right. Unexpected. I don't know how it managed to get outside of the bounds range. I can do this here. And then if we ever hit a point where if we don't care about anything else, actually, if chords equals exit chunks dot set chords chunk dot new exit. Now we need to figure out why we somehow hit a y past bounds dot y. Range is exclusive. We need to add 1 to these. Oops. There should be an exit in here. I don't see an exit. Oh, that's because I also need to yeah, continue. There we go. Right, we mirror things, so I can't continue out of this. I guess we just override it then. No, I don't need to do this check every time if we're just going to override it anyways. Let's move this back down here too then. Chunks dot set exit chunk dot new exit. All right, now let's bring back our walking algorithm to walk to our exit, which means we need to var diff equals exit minus start. And then we don't need this whole thing anymore, but go. Right. So next round, blah, blah, blah. We no longer need to check chunks.has. Here we go. We no longer need to do any of this. Thanks to the changes we just made. We do need to do this still. But before we do that, we need to... Actually, we don't need to do the mirrored one. We just need the regular one. So we can simplify that down. Chunks.get. Tile location. Our tile equals. All right, we call them chunk. All right, so we grab the chunk, and then if chunk dot value not equal to exit. No, let's do if the value equals any. Then we'll set it. Nope. Chunk dot value equals Paul. All right, we now have our most basic of basic paths in place. We need to ensure there's variability on every one of these levels, which means we should introduce some sort of block in the center that prevents pathing through there. The reason I'm thinking that is because if we block off pathing through the center, so we go around it, it forces us to, I guess we could also just randomly pick directions. Let's try that. Every other iteration, we will pick a random direction. Well, I'll just call count. Count equals 0. Count plus equals 1. So this first one will be 1. So then we can I am having a day. But we're pushing through and we're coding, so the run length, direction, so we want to alter our direction based on modulus. So this will be an elif, this will be an if count mod 2 equals 0. We will pick a random direction that's not. Do we want to head? Let's just pick random directions. For directions dot pick random. This will be direction equals. See what it looks like. Added a little more flexibility. It still feels like it's traversing. I'm wondering if I screwed something up in here. Count. We are incrementing count every time. If modulus hits 2, so it should be 0, 1. When it hits 2, it goes back to 0. That's what modulus does. It'll pick a random direction. And then it'll do a run length in a given direction. I am now worried about this going out of bounds, actually. I can do default values, right? Yeah. Chunk.new with nothing. It'll still get value as an object in there at least. Actually, let's do new. These are default, so might as well. And then we set it. And then just to be safe, what we can do is we can do chunks.set tile location chunk. They'll solve our out of bounds. We now have the concern that it can attempt to path directly backwards. So maybe we always path in the forward-facing direction. But we could, like, away from x0, which would require us to not use all 4 of these. Left is our last one. So we could do... I don't want to repeat it this much, but I don't know of a better way to do it in GD script. So 0. Do they have spread operators? No. There. Now it can never attempt to path back over our exit. There should be at least once every now and then where it goes the opposite direction of that path, but every time it seems to be going straight for the path, which means that this logic isn't working. So print misdirect. I mean, supposedly it's hitting. I wonder if this is a situation where it got here and it normally would have gone like right and then up or something like that, but it shot up. It just seems... Or like when it's hitting its misdirect, it's just undoing a phase. That was one. I just noticeably saw one, actually. I know what's going on. Let me just go ahead and ban that bot on Twitch real quick. I'm taking absolute values on directions, aren't I? I'm not. It's literally just adding... Wait, direction is a vector 2. Why am I doing a vector 2 on it? Oh. Direction is a vector 2, and I'm converting to a vector 2i. But these are vector 2i. Maybe that's what's going on here? Why am I using vector 2 instead of vector 2i on these? So I can get normalized. But that's easy enough. I can just do vector 2i here, which allows me to remove it from here. So let's see if that'll fix it. Shouldn't, but statistically speaking, this is impossible. It has to deviate at some point. Like, it would make sense in one like this, where, like, it shows up instead of right, something like that. But the fact that it's never chosen to go the opposite direction once is wild to me. Like, that's not statistically possible. Like, straight lines shouldn't be a thing either. And it's not like it's not happening. We're getting 4 calls to this, which means 4 times now it chose to do a random direction instead of follow on that last one, instead of following the normal path, and it still looked like a fairly like a straight path between the entrance and exit. So something's going wrong here. I wonder if it's something to do with this print chunk dot value. It's not getting weird loopback stuff. I know what's wrong. I'm not setting run length. Okay. Clamp range X, range Y, 1. It's just changing the upper bound. We will do offshoots as a do we just leave the upper bound unclamped? Yeah, I think we just let it go when we do random. We don't have to worry about overshooting because the loop will fix it eventually, is the idea. It fixes it eventually. All right, let's reduce variability on that a little bit. I guess it was too much. Let's set it to 1. No, set it to 2. This is actually pretty good. I don't really want our exits to be in the middle of a hallway, but we can use our waveform collapse to clear that up. These aren't getting as, I don't know, randomy as I had expected. I was expecting more like cornering style as opposed to like extra, you know, loops in the hallways and corners and things like that, as opposed to pretty much all of them being just, oh, we'll go in this direction. Just kidding. Dead end, turn back. It's like it randomly chooses a direction, and then the next iteration just immediately undoes that choice, and then gets to take, you know, one step to undo, and then one step in the direction it wants to go, and then the randomizer hits, and it has to undo it again, and repeats. That's not at all what I was going for. Maybe what we do is we actually set a few key points, one in each quadrant or something, and we then carve paths between them all. And we use one of those as the exit. We actually have logic to find the nearest path already, so we don't even have to make one of those an exit. We can just have the exit carve a path to the nearest hall. So if instead of setting one exit tile, let's set how do we want to do this? Let's do this as an array of exit is this line here. Let's do var points, sure. For I in range 4 points dot push back. I guess technically we don't actually have to store all those. We can create var point equals. Let's try this again. This. All right. And then I'll remove that. Within here, we move this into our for loop. We now calculate our, oh, I need the diff. We now calculate our diff differently. And we are looking at point instead of exit. Point instead of exit. Call you L. I don't actually use the variable here, do I? Let's get rid of this print. See how that looks. I don't hate it. If we do increase this, we get a lot more variability, but then there's nothing preventing things like this. If we modify the bounds, okay, this is gonna be weird. Let's do 4. Then we will set the toggling on Y based on a modulus. to if equal to 0. We will do 1 if that, else -1. Okay, and then let's set, so we got a 1. I want to do essentially the same, but I need to do it as part of this formula. And so we divide by 2 if I mod 2 equals 0. So that would mean latter half, no, equals 1, else 1. Now it should dump out 1 in all 4 quadrants. It doesn't look like it is. Because our iteration here would have a bounding point in the right half when, oh, right, I need to do the inverse of this. Equal to 0. That is really hard to read. I'm gonna have to rewrite that. Yeah, I'm gonna have to rewrite that. All right, so the x I mod if I mod 2 equals 0. Let's set var point as a vector to I unassigned. In the case where we've got the 0 case. So this will be 0 and 2 is our 0 and 2 case. We want it to be point equals vector to I of I want to do front half, then back half. That's where our problem is. Okay. So we actually need to, the reason this isn't working is because this always, when it's a 2, it's always the front. I'm sorry. When it's a 1, it's always the back half. And when it's a 0 or 2, it's always the front half. And so what we're getting is back half on a 1, lower. So it's always the bottom right quadrant and then the top left quadrant. And it's just bouncing back and forth between those two. So I need to do this as with a different formula. What if we just remove this restriction completely? What's it look like? It can't be 0. It's going to require a lot of cleanup. Those paths do not look good. I think a big part of it is because of the way we're generating points, but also the randomness of when the points come in. So it's just traversing back and forth a lot, which is adding a lot of fuzz. So I think what we might need to do is something like 4 point in points, and then we can set points equal to an array where each definition point will give you a static thing that we're looking at. So this is anywhere. If we do bounds over to here, then we get the latter half. Or sorry, no, the front half. And then we would do bounds times -1. So this would go it would traverse the front half. So bottom left quadrant. Then it would try and traverse to the top left quadrant. And then, so let's do like so. And then we will make this that. We will make this that. All right. So this is the bottom left quadrant. This is still on the bottom, but it's going to be anywhere in the bottom. So then let's take this side 2. Now it's the bottom right quadrant. And so if we take this, we'll do top left, top right. So now we'll hit at least 1 point in all 4 quadrants to set areas we want to hit. Then we can use these in here. This will actually go to the point itself. Let's try it. Yeah, it's still going to have that problem of, so it went bottom left, then bottom right, and then top left, and then top right. So it's a flow, which is kind of what I want to break. I think the next step here is to remove the linking between these two and start it as another entry point off of here. So I need to do this as 2 separate functions. So if I do points like this, then we would want to run this as another iteration. So to do that, we could nest our array. So now we can do underscore points. And then we just need to indent this. And we can do 4 point in underscore points. When we loop between these iterations, we need to reset our tile location. Tile location equals starter intersection. There we go. Some of these are going to be a little on the dull side. But we now have traversal between those. We could then close the final loop. which would require us to add a third entry here. Try and think of a good way to do this that doesn't require us to store different points or a bunch of extra variables or anything. It seems I missed our ad. Apparently we've also got pre-rolls on, so I need to get that turned off. So I need to run an ad to get pre-rolls turned off on Twitch. And also I need to go to the bathroom. So I am going to run an ad real quick and I'll be right back. And we're back. Oh, I just got a message. Unimportant. All right. So we need to store the final points so that we can try and connect them. Let's do points dot pushback. The problem is we're reassigning every time now. Oh, I forgot to grab water. We're I know what we could do. So once we finish this, we need to move to this. So points 1 dot pushback on points 0, 1. So we just push this into this array. We get some weird traversal on that one. That was an interesting one. Some of these look pretty good. And overall, I would say they tend to be the best we've had so far. Obviously, areas like this will just have to be cleaned up in our waveform collapse. Okay, let's add back in our exit carving. We have the exit already. Right? Yeah. So we just need to set, this is finding an exit, so we don't need this one anymore. This is what carves our exit. So we need to set tile location. Tile location equals exit. And so this will loop through until it finds, one layer at a time in straight paths in each direction, until it finds a neighbor. Or sorry, a chunk. Any chunk. It doesn't care. That being said, all we've put in so far is halls and our start and exit points, and we're at an exit point right now. So it'll carve that, and then it will, once it finds one, it will just follow that path, adding in our halls until it hits a tile, and then we'll add in an intersection. So now, right, we can't check on has tile anymore. We need to check and see junks.get chunk dot new dot value if the chunk is not equal to any. And then here, we get the tile. If tile.value equals any, update it to Hall. We stop one shy. If we change this to an elif on, then we would move this. Let's do var value equals that value. Let's do match actually. If it's an A, then we will do this. If it's an H, then we'll do this. And then we can remove that. And we can remove that. All right. Now we will create some sort of loop and then add our exit to the loop. That should have connected, it did not. Value is not equal to A. Right. It helps if I set my default value to A. All right, let's try it again. In the case where it spawns near the edge, we need to worry about that. This is an oddity. Yeah, so this would have been a case where it would have put one path here and then broke. Because it's closer to a non-existent tile than it is to a path. So that's working now. So now we have some level of interesting loop, which gives us players a reason to traverse areas and search. Now, I think we need to find large chunks of open area. No. I think we have enough now where you can just do a bit of cleanup. And then, do we even want to do the cleanup? Maybe we do something like if a tile has innies or nulls on 3 sides, we remove it. So, Hall. This will convert it into an intersection. So any area that gets those now have intersections. We definitely need to do the duplicate line. There, now we're getting intersections on those points. Let's see if I can get another. This is the intersection being added. I think we need to add back in the logic we used before for choosing an exit. Exit, exit. So let's do that. And then we can collapse all that. And we can go down here. While true. All right. Tile location equals this. Expected end of statement. Oh, right. I can't use that column. If chunks dot get tile location dot value is not equal to any equals any, then actually we can do this. We should do it this way. Chunks dot set tile location to a new chunk of exit type. And then we will break out of our while loop. Otherwise, we loop again until we find something that fits our requirements. I think we might need to do this as 2 passes. All right, so in this iteration, we'll iterate over the entire thing. I think what we need to do is match on the chunk value in our wave 1. We can remove any hull points that don't meet our requirements, but our main goal is to update all chunks. Yeah, we're at the point where we're about to do waveform collapse stuff, and our placeholder matching on value isn't going to work anymore. So let's fix that. So we needed to know let's move to the type system we started with for this. I don't think we're going to be able to use sides in this functionality. This is more of a, can a room be next to a hall, or does it need to be next to a wall kind of thing? Which is a purist form of the waveform. So that actually helps us a lot. I want to keep all of this, but I don't think it belongs in chunk. I think we need to introduce a new script. So let's introduce a script called tile. Tile can get all of this. We need to rename it to tile. It doesn't want to take in value though. So we're gonna remove that. This is going to be one of the last iterations we do on our waveform. All right, and then chunk. Chunk now no longer needs anything to do with sides. We want to take in enum chunk type is what we're working with, which will have hull. Let's do none. This has been our any so far. We'll do a hull, we'll do an intersection, we'll do start, exit, hull, intersection, start, exit. And then the placeholder tile has been pretty much everything so far. So working off just this, let's figure some stuff out real quick. We no longer need any of this. We can take in a underscore type of type, which we then can set type equal to underscore type, where type is defined as var type equal to type dot none. This needs to be a default value. All right. We don't want any of this. So let's switch over to this. We should be able to do chunk dot type dot start. Hall and intersection. And then this is a none case. This is the none case. This is the none case. This is the none case, and this is the Hall case. I should probably double check for strings as well when I'm going through this and not just be looking for errors. Should be good. This is collapse right now. This is the none case. This is the none case. This is the exit case. This is none. And none. And same there. And then this is the all and intersection. And then we can do none, all. We also have a wall. Let's add that. Technically, that doesn't exist as something we want to do in here. So let's not. If neighbor equals null, do nothing. Neighbor is not equal to null. No. And all. Let's see if this works. Oh, everywhere I use chunk.value is not dot type. Dot value. Does this have a? Does have dot type? Let's jump to the first one. Is there anything in here? There shouldn't be, but I just want to step through. Oh. This should be intersection. Start. Exit. Oops. Value. Did I not update my render? I did not update my render function. Start. So this one actually just goes away completely. This is now our none case. This is now our intersection case. This is now our all case. And this is now our end. We call it exit case. There we go. We're back to generating this with our new structure. Again, we have some wonkiness going on with structures like this. So before we do intersection adding, because this should just be trimmed down to having, like, all of these tiles should just be removed and these should have stayed as hulls. So the first thing I want to do is when we find a, let's do this in our collapse. Close that out. In our collapse, let's find where hall count, if hall count equals 0, this becomes an else if. I don't know how that ended up there. Then we want to set chunk dot type equal to chunk dot type dot none. Those should have got removed. I bet there was a tile here that got removed. It did remove one. Right, we need to account for start. So that's not going to work. Let's do chunk equal to trunk.chords. Bar changed equal to false. What we really want to do is write a wave collapse function that an outer loop that iterates and calls a function to handle the update. And then when we know if it, and when that function happens, it can call recursively on its siblings. So let's write a function. Func wave updater. The entire goal of this function is to perform the update logic. So it just needs to take in chords as a vector to I. And then as we iterate through this, it just needs to check the chunk type. Do some logic on itself based on its neighbors if it needs to. The first thing it actually should do is we need to know var collapsed. Let's do that so that in our collapse equals collapsed. Semicolon. In our map logic, everywhere that we have a dot new, no, set. Whoops. This is now a hauler intersection. We don't collapse those. They're in a temporary state. We do collapse exits though. Sorry. So when we're looping through this, if collapsed, return. Right. So we have a chunk from here. If chunk equals null or chunk dot collapsed, then return. So it's a short circuit. Otherwise, I don't think we need this anymore. Otherwise, we check the chunk's type. We will perform some logic. For now, I want to remove this. I'm going to go back to the logic we used to have here. It was jank, but we knew exactly what it did, and it worked consistently. If we set this to override, we should set chunk dot collapsed. True. This is incorrect, but I want to make sure this is working. Actually, I guess we could just write, let's strip this out and add our actual logic then, I guess. Actually, this is, no, we don't want to do this because we don't want to do this because the dead ends. We want to remove those before we lock in our intersections. So that actually is something we need to think about. Yeah. I was hoping to do as much, if not all, of the waveforms collapse logic in a single recursive function. And so my thought process here is we need neighbors. If an update happens, so I guess we do need that var updated equals false. we want this entire block of logic, actually. We want to take this here. And then we want a var neighbors plural, which is a array vector 2i. And then neighbor, if neighbor is not equal to null, and neighbors, we don't care about type here. So if neighbor not equal to null, do we want to bind coordinates on this? Because we do everything with coordinates, but then we have a I don't want to have to do the chunk lookup twice. So let's do neighbor chords var neighbors. And this one's an array of chunk types. And so if it's not equal to null, then we want to neighbors dot push back our neighbor. And then neighbor chords dot push back our chords plus dir. So that will get us arrays of all of our directions that have occupying neighbors. And their objects, or sorry, the occupying neighbors, and then the objects themselves. That way, in our logic down here, if we need to interact with a neighbor, like this one does, then we can, or sorry, if we need information about a neighbor, like this one does, then we can get it and use it. But in a waveform, all of them are going to require information. The reason we're storing the coordinates is so that if updated is true at the end here, if updated is true, then we want to call for chords in neighbor chords wave updater chords. Is our recursion. So if we update our chunk, we need to update all neighbors. That's part of the waveform and how we collapse it. And again, remember, if we've collapsed a chunk, it's now locked, and so we short circuit out of this. So we grab all the information we need about the chunk itself, as well as all of its neighbors, immediate neighbors. We only do the 4 directions. We then take into account the operations that should happen to this tile based on the information we know, which should be this one gets a little weird. We're still not quite in the spot where we want to do our waveform collapse. Now I'm thinking about it. The reason for that being is we use stepping functions to generate our halls initially and place a bunch of tiles and things like that. So we have all of the information we need to run waveform collapsing. But waveform collapsing is meant to happen based on like set values, and we don't actually have set values just yet. We have assumptions on our hall locations that need to be cleaned up. So I guess I need to write a cleanup function before we do that. Let's do hallway cleanup. Funk hallway cleanup. Should put it up here with these. So this essentially needs to do everything this is doing. So there's gonna be duplicated code, and I might be able to get away with it. It would require some abstractions that aren't gonna play nicely in Godot, though, unfortunately. Or another way that could potentially do it, it just feels wrong in Godot. We'll see. So, what do I need to do? I need to iterate through every chunk. Or sorry, every chunk. Checking to see if I don't need to iterate through every chunk. I need to iterate through every hall object. For chords in. Actually, is this giving me? It does give me coordinates, okay. Chunks. Bar chunk equals chunks dot get chords. If chunk equals null, or chunk dot collapsed, or chunk dot type not equal to chunk dot type dot hall. So if it's null, collapsed, or not our hall, then we will continue. From this point forward, everything we do in this loop is referring to a chunk of type hall. I need to know information about its neighbors. Is there a for each? Can I do for directions dot clone copy duplicate? I shouldn't need to duplicate. Dot for each. Is there a map? There's map function, okay. Hallway cleanup. Nope. Nope. Are there anonymous functions? Because I'd much rather do this as an anonymous function. GD script anonymous function. Lambda functions. Func message. Okay. Func. It'll be taking in a underscore. We'll call it direction. We'll just call it direction, which is a vector to I. and it will return a towards plus direction. Bar directions. Neighbors. These are our 4 neighbors. Is a much better way of doing it than the other one was. So this will get us our 4 neighbors. Then we can check all 4 neighbors. I really kind of need this to be bunk hallway cleanup. Takes in a cord void and then move pretty much all of this into there so that I can call it without the loop. This is vector 2i. Let me just check something real quick. All right. In this case, instead of continuing, we need to return. This will get our neighbors. We need to clean up chunk.type of hall. And we are interested in chunk.type of intersection. In the case of a hallway, if our hall count equals neighbors dot reduce bunk of chords vector 2i, which will return, oh right, takes more than just that. Reduce functions. Callable and an accumulator. The callable will take in an accumulator, then our value. ACC, which is going to be an int. Then base accumulator of 0. Right. Yes, okay. We need to return accumulator plus 1 if chunks dot get chords chunk dot new dot type equals chunk dot type dot hall else 0. So this will get us our hall count. If hall count is greater than 2, chunk dot type equals chunk.type.intersection. elif haul count equals 1, or sorry, less than or equal to 0, less than or equal to 1. In this case, we want to delete. We don't technically delete. We would be setting chunk.type equal to chunk.type.none. Yeah. Weird. But we only want to do that in the case where neighbors dot any func chords vector 2i return chunks dot get chords chunk dot new dot type equals can't be start technically chunk dot type dot end exit. Sorry. If any of them are an exit, not any of them are an exit. So we've got a haul count. This means a dead end haul that doesn't resolve in an exit at any point. Then we update this to none. We also now need to set, I don't think this one needs to trigger an update. This one does. And so we need to set var updated equals true. And so down here we can for chords in neighbors, hallway cleanup chords. Neighbor. Let's change these to be neighbor as well. This one should be chords though. All right. So if our current chunk type fits into this, we run it all. If we have an intersection, so we do all this logic for our hallways. I think the only logic intersection is going to need to do is double check this now that's been updated. Which means we need this. Do we want it? because this will convert to an intersection. This will convert away from a hall. Technically, we could run both of these like so. And that would work. Might have a bug. You need to check intersection here as well. Technically, we don't care about this because we use a switch statement. Updated. If updated. That's probably our problem. Infinite looping, that's bad. Maybe I should be setting these as we step up above. Let's drop this, see if this works. All right, so this is still working. Fully working as expected. The problem we're having is when we try and handle our neighbor count less than equal to 1. How frequently is this firing? One, two, three. That was a lot more than 3. Our logic might not be working. Neighbors, reduce. Accumulator, plus. Do I need to wrap this in? Do this so it's a little easier to read. That's, once again, that's a lot of hits. Way less, though. But none of these should have... There shouldn't be any hits on this. Actually. I don't account for... All right. So this has 1, 2, 3, 4, 5, 6. So if we do 1, 2, 3, 4. I mean, if we count these two as well, which it would because we're not... Yeah, so 5, 6. So it's not accounting for intersections or start in tiles is our problem. So we want to remove this. We need to account for intersections, start and end. So print it. Includes has work. chunk dot type dot exit chunk dot type dot start chunk dot type dot intersection. Strat. No hits. It should have had a 1. We don't need intersection here. Right? Exit. Start. Wonder why that's causing so many issues when I remove intersection. Should just be printing. It's printing everything, is my only guess. If I set this to 0, it should be an intersection now. So I shouldn't have to worry about intersection. Interesting. It shouldn't be having a problem with that. Oh, on occasion it has a problem. That's even worse. This should be getting hits. All right. It looks like the ads are being wonky again and pre-rolls have started, but we got 20 minutes before the next automated ad. So I'm going to go ahead and run ads now and refill my drink real quick and go to the bathroom. So give me a couple minutes now. I will be right back. As soon as I find the button. There we go. And we're back. Oh, I should probably check my message real quick. Okay. So this isn't updated, so it shouldn't be hitting any weird recursion issues. It's merely just checking an array for a type. Interesting. Should be 0 hits. Should have 1 hit. Got it. 0 hits. This one had 1. Oh, it would have been this corner up here. Ooh, that will actually help a little bit. Let's do this and see what happens. No weird bounds. This one has an oddity still. This should have hit, cleaned up 1, if assuming there was 1 here. Then called its neighbors, cleaned up, called its neighbors, cleaned up. But oh, it's because it's too long. I need to know. If I set this to 1, it'll remove lines not connected, or it'll remove lines up through intersections is the problem. So I need to exclude intersections here. So if it's next to an intersection, it gets excluded, which then means it won't do cleanup of the last thing because it's next to an intersection. So I need hall count 0 and not chunk dot type dot start. No. The problem we're running into is we got some edge cases that are to lay these out. Hall, intersection will not get cleaned up because this hall has a neighbor, and so we increase this to 0 from 0 to 1. Now, once it's cleared up, this will get deleted if we're not checking for intersections here. But this is greater than or equal to 1, which means if we have, so let's say intersection, hall, intersection, there's no point where there's 2 halls next to each other. So both of these will get cleaned up in between these intersections. So when it's hall count of 0, the only way it can trigger that is situations like this. And be in a point where it would be an issue. Let's do this. And then if this dot has so we care about exit, start, intersection, or chunk dot type. I guess I could do none. Turn 0 if none equals type, else return 1. Now it's called valid neighbor. And so neighbors, let's make it plural. If there's valid neighbors of 2 or more, it becomes an intersection. Else if the valid neighbors is less than or equal to 1, we remove it. Because now it accounts for everything that's considered an enabled neighbor, not just our hallways. Okay. It's a little odd, but technically that's correct. We can then do some culling on double neighbors. Again, weird, but correct. This probably shouldn't be an intersection. So valid neighbors greater than 2. Oh, we should probably be setting updated equal to true here. I'm willing to bet we culled a dead end off that, and that's why I did it. Sometimes it hangs. That's a problem. Damn it. I need to stop closing these whenever I run into an error. I'm trying to recreate an error I saw a little bit ago, but every time I close it, it clears the debug logs. There we go. Check for infinite recursion in your script. So the hanging isn't actually infinite recursion. I don't know if this is actually infinite recursion or not, or if it's just that our max stack size is only 1024. Huh. I don't think we need to distinguish between intersections and neighbors anymore. Or sorry, hallways anymore. So if I remove this, we have this much smaller case, so it's less likely to trigger problems here, which will help. We can get rid of intersection here. Let's go to chunk intersection. This can just be hall. And we no longer run or I in range of count. Right. This traverses until it saying this, and so we just want to do nothing in that case. This is our wave updater. So this is just invalid now. Also, this is all invalid actually. And then we can remove this. We no longer have intersections, but intersections are just a variant of hallway anyways, based on their neighbor choices. This is a problem. I don't know what's causing this. And I don't know if it's my code. I don't know if it's like it's just hung. It didn't give me an error or anything. It just never loaded in. All right. We do need to account for the double tile somehow, though. If I think when we're placing our hallways, we can restrict back. So if a tile is attempted to be placed and it has 3 out of 8 neighbors. Yeah, so if we go up here to our traversal function, if we go to place a tile, so we've got 4 directions, const 8 directions equals 4 directions dot duplicate dot append array for vector 2i of 1 1 1 negative 1 negative 1 1 and negative 1 negative 1 negative 1. Cannot get return value of. Okay, so I need to do this and then 8 directions. Damn. Does it assign? Nope. Okay. No, that won't work either. And not having access to things like spread operators is annoying. Let's just do them as separate then, and we'll do the diagonal directions. So if when we go to place a tile, which means we need to find our set. When we go to set a chunk type hall, not this one, it would be this one here. This is our, yeah, so it wouldn't need to be that one either. We just need it here. So if it attempts to update this tile, we first need to check all directions to get a count. And if that count is, so we have 9 directions or 9 tile options in our area that we care about right now. So let's do hall, none, none, hall, none, none, and then hall, none, none. If we were wandering a second path through here and we hit this tile, when it went to set it, you know, it's traversing up, and then we would just assume that down here is none. It's traversing up and it hits this tile. It finds 3 neighbors as halls, so it would not do this one. It would then traverse to this, attempt to do hall, and it would check, you know, the tiles up here as well. But if it didn't find 3, then move on. The problem I'm worried about is in a situation where we have something like that. No, that would be fine. If we had double hallways 1 wide, it wouldn't go here because it sees 6. Even though this is technically valid, it's really only invalid when you have the corner cases, to be honest. Like if this is a bar all the way down and then you have either below or above, or it's a bar all the way across and you have, you know, behind or ahead. So we want to avoid the 2 touching parallel lines. But I guess I'm okay with this as well not being set. Are there, I don't think there's any case when there's more than 3 that we would want to keep. Because even if this is, if all of these are none, and it comes in from the end here, all, it would reject this. Which is fine. But that same scenario again where it goes to place this. If there's a line here, let's assume we have this makeup and then it's coming in a line from the right. It would check this one, sees there's a hall there. There's nothing else around it. It just has its 2, the line coming in, and then it would check this. And it would see 4 tiles and reject out. Even though we need this to be a hall in that case to connect these. And we would want this to not be a hall. Oof. It makes me think as we're traversing, we need to start introducing all of the helper methods or the helper information into our options for the waveform to collapse against. And then instead of statically setting, hang on, I just got a text message. Is a weird one. I think I am going to have to, instead of solidly setting this, we are going to have to start supplying to our chunks our options, which is a array of type. And if we I guess what are we defining as our logic? That's what I need to do. Halls can go next to a hall. 1 to 2. No, because we have intersections that are 4. They actually need to be 2 to 4, which means, now I'm thinking about this, if we go back to our logic, if I up this to where it only removes the cases that are this case where it's trying to drop a hall right here. Again, we want this case though. Because if we only look at the cardinal directions, then we can have options where it has all 4. It's just this can't be next to one that also has that same scenario. That's why we initially introduced the intersections. I think we might just change the logic here. Not here. And so instead of doing it in here, we grab this. Call. So instead of neighbors doing the 4 directions, we can duplicate the 4 directions, and then we can append array as a duplication of the diagonal directions. And then we can neighbors.map. Does this return a value, or is it a void function? Cannot get a return value of call append array. Well, once again, I need to do that, and then neighbors.append. It returns an array, so I actually need to set neighbors equal to that. Now we have, instead of just the 4 main directions, we've got all 8. That screws with things, though. Because now it won't call things correctly on diagonals. All right, well, I need to run another ad, so we'll be right back. I'm going to do a 3-minute ad this time, buy us a little bit of extra time. Hi, and we're back. I just realized, timing-wise, that we do need to wrap up here soon. I am struggling with thinking through this logic, so it's probably best if we wrap up pretty soon from that standpoint as well. Mine's a little distracted today, unfortunately, but it happens sometimes. Our concern is an inability to access the exit from the entrance. So if we strip back all of the logic, if we strip back all of the logic so that we're still creating the area, because that was one of the issues we were having early on, dynamically sized, creating the area, then place the exit and traversal path just to the exit instead of trying to create our corridors initially, we won't have any of these weird conflicting issues. We can collapse all of those. When we collapse those, we can update their neighbors. And that will lock in the seed for our waveform to collapse against. We are making a game called Psychocats. It is a stealth-based roguelike where you play a cat that has developed psychic powers and has been trapped in a laboratory, and you are trying to escape. Let me see if we can run it right now. I don't think this is linked in. I think we were running the scene directly. So here's all of our cat options. So you can pick one of these guys. And of course it won't load in. Let me update our level selector to go back to using the is it game script? Going back to using the static levels we were working against. Levels. Where's the function that references this? Levels. I want to set current level equal to next map. So it should be setting to level 1. Okay, did we change the scene? No, our scene's still the same. Interesting. Oh, did we? Oh, right. Game scene. We got our lighting set. Did we turn off our lighting on our player? I think we might have, because it was doing some weird things. Player scene. We did turn off lighting and camera. There we go. Am I supposed to be doing this in the game scene? Here we go. It should be going through our enabled cycle, actually. We shouldn't need to change that. I'm not sure how I added another cat back in. That's fixed. This is going to be weird. This is what we're working on right now. Our pathing algorithm is what this weird line coming out of this is. But we got the... Oh. Wait. Cat chasing. So we've got our vision cones, our line of sight detection, the collisions, the we can bake our scenes. So for AI's navigation, I've got the debugging on for navigation right now. I have not baked this scene, so it's a little weird. We've got the lose state for what happens when you get caught, all that stuff. Yeah, I want to introduce obstacles. So we will have like walls function as blockades for the player and the AI. that works pretty normally. The did it bake across this? No. Interesting. I want to introduce like obstacles that, as the player, because again, you're playing as a cat, that you can go through, but enemies can't. I need to add in the Y ordering, or the Y sorting, to get leveling stuff handled correctly. And then right now we're working on setting up how we want to do our procedural generation of levels, which I'm spending a lot of time on it right now because it's a stealth-based game. So it falls pretty heavily, because there's no combat in it. It falls pretty heavily into an area that I would normally consider puzzle games. And so getting our procedural generation to work correctly and make it feel good from a puzzling, like problem solving standpoint, I think is going to be important, because I want the players to be able to stealth around through areas as best they can. And then the longer you take, the higher your threat level will go within an area until, they'll start hunting you down regardless. And so if you can do it quickly, you can stealth through a zone pretty fast. But if you take too long, you dawdle too much or something like that, then you need to start using the blockades, which is the obstacles the player can go through, but the AI can't. So you start utilizing things like the blockades to ditch AI chasing you and figure out how to dodge the rooms and stuff. So it'll transition the longer you take between more stealth focused to more like evasion focused. That's kind of the idea we're going for. We started it last weekend, so I guess we're coming up on a week now. Technically, is today Thursday? Yeah, today's Thursday. So we started it 10 a.m. ish. We started coding 10 a.m. Sunday, and we looked at the theme 10 a.m. Saturday. So, and I've spent the last 2 full days, well, today and all day yesterday for sure, just doing procedural generation. So I am expecting my partner to be home any minute now, and I am going to have to help with groceries and such when that happens. Maybe. She's at our neighbor's house right now, so maybe not. It depends on the game and the implementation style. So, for example, Binding of Isaac falls under random generation, which is handcrafted rooms with things that can randomly spawn in them that are then randomly connected together. Procedural generation is just randomized generation with rules. And so you can build the same functions by just saying, when this tile is placed, the neighbors can be these options. And then you pick a neighbor and you resolve that, and so on and so forth. I have not. I'm gonna have to look into that. Are you talking about Repentance, his like follow-up to it? The DLC released in 2021, or? Oh, really? Mugenics. I'm a huge fan of that art style. That's awesome. I have not seen that. I didn't know he was working on anything like that. That's cool, though. But how you handle procedural generation and the rules you give it and stuff is what really does a lot of the determining for it. What we were working on, although I don't know if it'll actually function in its current state. Let me get the correct, so it should be the level scene. So the purple tiles are currently blank tiles. Those will be collapsed. The gray, the solid gray tiles are what I consider hallways. And then the checkerboard ones, the one all the way to the left is the start point. And then the one within the bounding square is the exit that you'd be going for. And so that's what we're generating now. And I've been toying around with different options. Right now, it's utilizing one where it picks each of the 4 quadrants gets a point, and it will resolve a path point to point across all of them, which is why we always have a loop. Once we have that loop, it will then find, in some cases, it gets weird. But, you know, and then once we have that point, we will then set the exit location and we'll draw the shortest path to connect to that hallway. And so I do run based paths instead of diagonal paths because I don't want to do diagonal corridor connections. So it does a maximum distance in a direction, and then it will recalculate and determine if it should corner or not, which is why all the hallways come out as kind of like hallways, you know. Some of them, like this one, actually pretty good. There's a dead end hallway that should be getting cold, but it's not. But aside from that, this one turned out really good. And so I need a way to either check if a map is, you know, good or not, like how good was the generation, or what I think I'm going to do instead is I'm going to trim back the algorithms to where it does the point to point like we were doing initially, just that one hallway, but leaves the container body in place now. So I can use the container's sizing as our bounding box for doing our waveform. It's what I'm thinking. I'm not sure. Either way, I think I'm going to have to lock in a singular hallway and then set tiles that touch my hallway tiles with options. I think that's going to have to be the direction I go. And then I can waveform collapse from there. Because once I've collapsed in the start and end point, and we have, I mean, technically we just need to start an endpoint, but the big concern I have is if we're generating these procedurally and it's just pacing out on what can or can't happen in each direction, I'm worried that we're going to end up in a situation where we have, you know, start and endpoints don't connect. That's going to be a problem. And so we need to make sure those are a thing. So how we connect halls is going to be the big, you know, issue. I could do a lattice. Our initial seed contains all structured hallways that can then be removed. We choose a side, we seed it with a bunch of hallways. We connect the endpoint to, or the exit to, you know, the start and the exit both to the grid of hallways. That would give the nice squared cornered, like man-made feel to the way the layout for consistency. Then we can utilize a point of interest system placed along hallway tiles. And we would just utilize that to cull out areas, maybe. Even just using a grid system, I think would improve the feel quite a bit. I could downsize the map stepping generation. So as the, depth or level increases, it doesn't get that much bigger. If we use a static structure, then it's a matter of just figuring out where the exit is, which would solve some of these problems. I can then find bounded areas as part of the waveform collapse. So areas completely surrounded on all four sides by hallways. So an enclosed area, and then that becomes a room. I don't even need to waveform collapse on that. I can just do that as part of the generation, define my room type. Then we'll have hallways and rooms in a grid structure. We cull any partials off the edges, which gives us a more, odd, interesting shapes. We could even cull the occasional room completely. So if we determine a run size, now we've got variable run sizes. So let's generate grid structure. Sure. I think I want to take this in its entirety, actually. The remainder of this that is a little more intricate here is this. So let's start by commenting out what we want to do. Create set and exit. Then we will create step based grid structure. Convert enclosed rooms to room POIs. Set doors for rooms. Don't think I should do this. I think I should leave the... No. Maybe it would make sense to go ahead and generate pretty much everything from a structure standpoint. So yeah, we'll leave that on how things connect. So our entrance points, and then we will have cull outer edges. We might even want to go so far as to cull excess POIs. We might need to introduce I think we're going to have to introduce a system for setting up the like a running counter on how many POIs or whatever we have. That way we can set how many rooms we want to generate within our structure. And then we can use the waveform collapse functions in much smaller snippets on a given POI area. And just be like, here's a door. Maybe we'll have multiple doors. I don't know. We'll have set walls that are, guaranteed. And then we can use it to just generate the interiors for it. Or maybe we write another middle ground procedural generation like what we're doing here to have a little less randomness and a little more structure. Because these are intended to be man-made structures, which is one of the problems I'm struggling with the waveform. It works great when you want pure randomness that follows rules. But we don't really want pure randomness. We want something that feels man-made, which has some more rigid structure to it. Yeah, I think this should be our initial rule set. Okay. I need to run... yeah, it's 3:30. So I need to run and go handle some things. We've got some bad storms coming in, and I got most of it done, but I need to handle a couple more things before dark tonight. So thanks for joining me. I appreciate it. I will be trying to get back onto my normal streaming schedule. Hopefully tomorrow. Again, I don't know how we're going to fare with the storms, so I might or might not be able to stream tomorrow. And they're expecting these storms to be pretty bad, so I might not have power come next week or something as well. So we will see. Hopefully it shouldn't be an issue, but time will tell. If everything goes to plan, 10 a.m. tomorrow morning, 10 a.m. Central, which would be 11 a.m. East Coast or Eastern Standard Time US, or 8 a.m. Pacific Standard Time, is the target we have every day. Usually it's between then and 11. If I make any changes to that schedule, you will hear from me on our Discord, which of course is linked down below in the About section on Twitch and also YouTube. So again, thanks for joining me, and I will see you guys tomorrow.